Hello friends, welcome. Friends, today I teach explain average velocity for motion in a plane. Friends, first of all look here this figure. Here now we have one particle P. R is a position vector of this particle. And this particle is moved this way. So here R is also position vector. After time delta t, this particle is reached at point P dash. At that time, its new position vector, it is denoted by vector r dash. Means in time delta t, its x component and y component are changed. The average velocity v of an object is the ratio of displacement and the corresponding time interval. Suppose the object curves delta r, displacement in time interval delta t. So according to definition of average velocity, we can write down average v is equal to delta r upon delta t. Here delta r is a displacement. So instead delta r we can write down its two components x and y, means delta x I caret plus delta y j caret upon delta t. Now we separate it. So we can write down I caret delta x upon delta t plus j caret delta y upon delta t. Friends, here delta x is a displacement and delta t is a time. So according to definition of velocity, we can write down here instead delta x upon delta t vx. And same way we can write down delta y upon delta t here vy. So we get average v is equal to average vx I caret plus average vy j caret. Since average v is equal to delta r upon delta t, the direction of average velocity is the same as that of delta r. Next question is explain instantaneous velocity for motion in a plane. Friends, look here. Now we have A, B, C and D four figure. In figure D, now we have one particle at point P and its position vector is r. And in figure A, look here. This particle is moved from P to P1 and at that point its new position vector is a r1. Same way, in figure B, particle is moved from P to P2 and at P2 its new position vector is r2. In figure C, the particle is moved from P to P3 and at point P3 its new position vector is a r3. Means suppose object curve delta r displacement in time interval delta t. So according to definition of average velocity, we can write down average v is equal to delta r upon delta t. Okay. Look here. From figure A, B and C, we can say that after time interval delta t1, delta t2 and delta t3, delta r1, delta r2 and delta r3 are the displacement of the object in time interval delta t1, delta t2 and delta t3 respectively. and instantaneous velocity is given by limiting value of average velocity as the time interval approach 0. Now we take limit, means average v is equal to limit delta t tends to 0 delta r upon delta t. When now we remove the limit, at that time we can write down d instead of delta. So average v means vector v is equal to dr upon dt. And the direction of velocity at any point of the path of an object is tangential to the path at that point and is in the direction of motion. And friends, we know that the unit of velocity and instantaneous velocity, also average velocity, is meter per second in MKS system. But in CGS system, unit is centimeter per second. Explain component of velocity for motion in a plane. Okay, average velocity v is equal to delta r upon delta t. Friends, instead delta r we can write down delta x I caret plus delta y j caret and separate them. So here we get average v is equal to delta x upon delta t I caret plus delta y upon delta t j caret. Okay, both are equation same. By taking limit delta t tends to 0, instantaneous velocity is obtained v is equal to I caret dx upon dt plus j caret dy upon dt is equal to, here this is not minus sign, is equal to, instead dx upon dt we can write down velocity vx I caret plus vy j caret. Look here, where available vx is equal to dx upon dt and vy is equal to dy upon dt. So if the expression for the coordinates x and y are the known as the function of time, we can use this equation to find vx and vy. And friends, now we want to find out magnitude. So now we take root, means v is equal to vx square plus vy square. Look here, suppose now we have one particle, its velocity is in this direction, vx is x component of velocity, vy is a y component of velocity, between them angle is suppose theta. So according to definition of tan theta, we can write down tan theta is equal to opposite means vy upon near side means vx. So theta is equal to tan inverse vy upon vx. With the help of this formula, we can find out how many angle between y and x component. So friends, with the help of this formula, we solve so many questions. So please try and solve it.